Hi, today we'll study about coordinate geometry of Mathematics Chapter 7 for Class 10 as per Karnataka State Syllabus. Please note down all the important points as the same will be helpful for you in the examination. Welcome you all. Section 7.1 Introduction. Coordinate geometry is an algebraic tool for studying geometry of figures. It helps us to study geometry using algebra and understand algebra with the help of geometry. Coordinate geometry is widely applied in various fields such as physics, engineering, navigation, and seismology. In this chapter, we will learn how to find the distance between 2 points and to find the area of the triangle, and also study how to find the coordinates of the point which divides a line segment. Please see the figure on the right hand side. This is a replica of a graph sheet. In the x-axis, x coordinate numbers for each column. That is, this vertical line is a column. So it is numbered as 1, 2, 3, 4, 5, 6 and up to 10, and this can go on and on. These are the positive sides of the numbers. Similarly, we can have on the left hand side. This point is called origin. On the left of origin, we have the negative numbers which are numbered as -1, -2, -3 and -4. For the purpose of simplification, we have avoided the negative numbers. These numbers on x-axis are called x-coordinate or abscissa. Please remember, these numbers horizontal on the x-axis are called x-coordinate or abscissa. Similarly, on the vertical side, we have numbers 1 to 8. These represent the horizontal lines parallel to x-axis. So this is 1, 2, 3. These are numbered as 1, 2, 3, 4, 5, 6, 7, and 8 and so on. These are the positive side. That is, the upper side is a positive side. And this positive side or the sides on the y-axis is called y coordinate or the ordinate. Hence, this is a y-axis and horizontal one is the x-axis. Similarly, we can have these numbers are in the vertical side. We can have on the downward side. This origin is always called 0 and 0. This point is 0 and 0 origin. And the downwards the numbers are negative. That is, we start with -1, -2, -3 and so on and so on. This is the negative y, minus y. This downward side is represented as minus y. Hence, let us summarize. The x-axis is x coordinate or abscissa. Y-axis is y coordinate or ordinate. And the numbers are starting with 0, it goes on and on. In the figure, it is shown up to 10. That is, x-axis is up to 10 and y-axis is shown up to 8, number 8. Any point on the graph can be represented as a ordinate or coordinate. It is called, say, consider a point A. A is located at a distance of 3 points from the origin. That is, A is horizontal is numbered, that is number 3, and Y is here 1. So A is represented as 3, 1, that is XY. first letter is X and next letter is Y. Similarly, a point B is also shown in the graph sheet. The horizontal distance is X here and the vertical distance is Y. So, horizontal distance if we count it is 6 and vertical here if you see the horizontal line it is 4. So, therefore, B is represented as XY, that is 6 comma 4. The third case also let us take. Here consider a point C. Point C is located at a distance of 8, that is x is equal to 8, and vertical rows are 6. Therefore, C is represented as XY. X is 8 here and Y is 6. This is the graphical representation of coordinate and ordinate, that is XY. Each point is represented as XY. For example, A is X1, Y1. X1 is equal to 3, Y1 is equal to 1. Similarly, point B is represented as X2, Y2. That is X2 is equal to 6 and Y2 is equal to 4. And C is also represented as X3, Y3. Here X3 is equal to 8 and Y3 is equal to 6. The distance of a point from y-axis is called x-coordinate. Hence, from the y-axis, this is y-axis and the distance is called x-coordinate. Hence, this is called x-coordinate or abscissa. The distance of a point from the x-axis. So, from the x-axis, this is the horizontal line and we are measuring distance on the y-axis. And distance is measured from the x-axis and it is called y-coordinate or ordinate. The coordinates of a point on the x-axis are of the form x comma 0 and of a point on y-axis are called 0 comma y. Hence, y-axis is x-axis is represented as x. Here y is equal to 0. Here on this line y equals 0 and x is represented by 1, 2, 3 or etc. And on the y-axis, this is y-axis and distance coordinates are y-axis are 0. That is y is equal to 0 and x is equal to 0 and y is represented as 1, 2, 3 like this. So, these points as I explained you earlier, coordinates of points are A is 3 comma 1 and B is 6 comma 4 and C is 8 comma 6. These are the basics and fundamentals of coordinate geometry. Let us take up 7.2. Section 7.2. Here we represent points Px1 and Qx2, Y2 as a given formula is given as x2 minus x1 whole square plus y2 minus y1 whole square. Let us study the drawing on the right hand side. Here OX is a x-axis and OY is a y-axis. This is a graphical side. Starting point is O, origin. Here we have 2 points P x1 y1 and Q x2 y2. So the distance between P and Q, this is the inclined line. It is given by the formula x2 minus x1 whole square plus y2 minus y1 whole square. This is using Pythagoras theorem. If you see here, point P is given by x1 y1. So this is x1 is this distance and y1 is this distance. Similarly, point Q is given by x2 y2 and this is distance x2 is this much, y2 is this much. Now we have to represent PQ square We know using Pythagoras theorem in this triangle PQT, hypotenuse square PQ square is equal to QT square plus PT square. But QT is the vertical distance y2 minus y1. Similarly, PT is x2 minus x1. Therefore, PT square plus QT square, that is equal to PQ square. Using this formula and removing the and using the square root sign, we get the distance PQ is given by x2 minus x1 whole square plus y2 minus y1 whole square. If we take, this is located away from the origin. If we point P is located at the origin, we put P is equal to xy and O is 0, 0. Therefore, if you want to measure the distance here, you put x1 is equal to 0 and y1 is equal to 0. Therefore, we get the distance of P from O is given by x square plus y square. In this equation, if you put x1 equal to 0, we get x2 square plus y2 square. That is as good as x square plus y square. Point number 3. The coordinates of the point Pxy, which divides the line segment joining the points Ax1 y1 and Px2 y2 internally in the ratio m1 is to m2 are given by the equation m1 x2 plus m2 x1 divided by m1 plus m2 comma m1 y2 plus m2 y1 divided by m1 plus m2. Please see there are 2 points A and B. These are represented by x1, y1. These coordinates of point A are x1, y1 and coordinates of B are x2, y2. Now we have to find out the midpoint P. That is, this is point P such that which is dividing this line AB in the ratio m1 is to m2, and this derivation you have to remember as the coordinates of point P. Here we have to find out x and y as m1 x2 m1 into x2 plus m2 into x1. m2 into, that is a cross, you see m2 into x1, m1 into x2 divided by m1 plus m2 comma, and y coordinate y is given by m1 y2 plus m2 y1 divided by m1 plus m2. These formulae you remember and it will help you in solving the problems. Now let us take up some problems. The midpoint of line segment joining point P x1 y1 plus x2 y2. Here we have to find out the midpoints. x2 y2, it is given by x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. That is in the midpoint we take m1 is to m2 equals to 1. Therefore, we will get m1 is equal, in the previous formula if we put m1 is equal to 1 and m2 is equal to 1, we get for equation P as a midpoint as x1 plus x2 divided by 2 plus y1 plus y2 divided by 2. In the figure, let us take the numerical example. Here we have 2 points A. A's coordinates are 7 and 1, that is x1 is equal to 7 and y1 is equal to 1. And similarly we have a point B which is 3 comma 5, that is x2 is equal to 3 and y2 is equal to 5. A straight line x minus y is equal to 2 intercepts this line joining AB. It intercepts at this point P. These equations we will solve in the subsequent examples, but here for explanation purpose I have given this figure to show that this line x minus y is equal to 2 is intercepting at the point. Now we will take up the area of a triangle. Using coordinate geometry we can find area of a triangle also. Triangle has three corners or three angles or 3 points. Point A x1 y1 and point B x2 y2 and point C x3 y3. These are the three numerical value of the expressions. Here you please see the figure, the second figure. As pointed out by this pointer, we have A x1 y1, B x2 y2 and C x3 y3. With these coordinates, we have to find the area of this triangle. This area of triangle is given by the formula half into x1 into y2 minus y3. See, you take for example the first point, half is common to all the numerals outside the bracket, big bracket, and it is x1 into y2 minus y3. Similarly, plus x2 into y3 minus y2. This is opposite side you take, y3 minus y1, and x3 into this x3 you take, and it is into y1 minus, this is y1 minus y2. This is the formula. It is very easy to remember if you draw the diagram and write the coordinates correctly. A is x1 y1, B is x2 y2 and C is x3 y3, and the area of the triangle is given by this formula. Please remember, this will be helpful for you. Now let us take numerical examples. 7.4, solve the following. Find the coordinates of the point which divides the line segment joining points 4, minus 3 and 8, 5 in the ratio 3:1. So here m1 is equal to 3 and m2 is equal to 1. This is a 2-mark question and it is very simple. You have to substitute the formula and correctly write x1 y1 and x2 y2. Let us solve it. Please see the figure. Though the figure is not given in the question paper, for the purpose of understanding and explaining, I have given repeated the figure which was given earlier in this presentation. Here is a point A, x1 y1, B x2 y2 and P is xy, and it is dividing in the ratio m1 is to m2. Here A is 4 and minus 3 and B is 8 and 5, and ratio m1 is 3 and m2 is 1. Let us solve it. Given A is equal to 4, minus 3, B is equal to 8, 5, m1 is equal to 3, m2 is equal to 1. So A x1 y1 and B x2 y2 is given by the formula m x1 x2 plus m2 x1, m1 plus m2 and m1 m2 plus m2 y2 divided by m1 plus m2. Therefore, substituting and solving for x and y, we get, let us substitute. m1 is 3, x2 is 8 and m2 is 1 and x1 is 4 divided by 3 plus 1, comma, and the y coordinates are 3 into 5 plus 1 into minus 3 divided by 3 plus 1. That is equal to 3 into 8 is 24 plus 4 divided by 4 comma 3 into 5 is 15. 1 into minus 3 is minus 3 divided by 4. So the coordinates are 24 plus 4, 28 by 4 comma 15 minus 3 is 12, 12 divided by 4. That is 7. 28 by 4 is 7, 12 by 4 is 3. This is the answer. Therefore, we have found the coordinates of the point P such that x is equal to 7 and y is equal to 3. Coordinates of point which divides the given line are 7 and 3. This is the answer, and this is a 2-mark question. Then section 7.5, solve the following. If the distance between points P 2, minus 3 and Q within brackets 10, y is 10 units, then find the value of y. Please read again. This is a 2-mark question. The distance is given as P is xy 2, minus 3 and Q is 10, y. The numerical value of y is not given here, and he has just given it as y, and he has asked us to find the value of y if the distance, the final answer is 10 units, is equal to 10 units. We have to substitute these values in the formula. Let us solve it. Please see the figure. For the explanation, I have given it as it is: P x1 y1, Q x2 y2, and we have to find out, and the distance PQ is given as 10, and we have to find the y2 here. Here we have to find out the value of y2 in the figure, but actually in the equation it is y. All other values are given, that is x1 is 2, y1 is minus 3, Q of x2 is 10 and y2 is y, and the total distance PQ is 10. Let us substitute. Solve. Given P is equal to 2, minus 3, Q is 10, y, and distance PQ is equal to 10, and we have to find the value of y2. The distance between between two points P x1 y1 and Q x2 y2 is given by the formula D is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This is based on Pythagoras theorem. That is, hypotenuse square is equal to sum of square of opposites at the other two sides. Substitute. X2 is 10 and x1 is minus 2 whole square plus y is as it is, y2 is y minus of minus 3 whole square. So that becomes 10 minus 2 is 8 whole square plus y plus minus into minus, it becomes plus y plus 3 whole square. Therefore 10 is equal to square root of 8 square is 64, plus we have to expand this y plus 3 as a plus b whole square, that is a square plus b square plus 2ab. That is, this 64 plus y square plus 3 into 3 9 plus 2 into 3 y, that is 2 into 3 is 6y. Therefore, squaring both sides, we get 100 is equal to 64. 64 plus 9. 64 plus 9 is 73. This y square as it is y square plus 6y. Therefore, simplifying, we get y square plus 73 plus 6y, and minus 100 taken on the right side changes the sign, minus 100 equals 0, or y square plus 6y minus 27 is equal to 0. Then again factorizing this, we get y square plus 9y minus 3y minus 27 is equal to 0. Here we get two factors are y into y minus 3 plus 9 into y minus 3. Taking y common between this first term and the third term, we get y, if we take common, y minus 3, and this becomes plus 9 if we take common, y minus 3 equal to 0. Therefore, y minus 3 equal to 0. The two roots are y minus 3 equal to 0 or y plus 9 equal to 0. Here, if we take y minus 3 equal to 0, then y becomes 3. And if we take y plus 3 as 0, y equals minus 9. Distance cannot be negative. So hence, you neglect this value and take y is equal to 3 is the answer. Example 7.6. Solve the following. If the point A 6, 1, 6, 1, B 8, 2, and C 9, 4, and D P, 3 are the four vertices of a parallelogram taken in order, find the value of P. Here it is given it as a parallelogram as given, and parallelogram has four corners, and four corners are given as vertices. It is also called vertices. A 6, 1, B 8, 2, and C 9, 4, and D P, 3. So here we have to find out the value of P. So these given values you have to write. You have to see in every problem you have to write the given values. For this also you will get some marks. This is also shown in the figure. A, B, C, D, and the respective points are also. You please note down. A is 6, 1, B 8, 2, C 9, 4, and D P, 3. And the midpoint formula for any line, consider the line DP. D and B a point here, and we have to find out the formula for midpoint. Similarly, you consider the point A, C, and it's calculate the midpoint of this. So when both are intersecting at such point, and the coordinate must be same. So first let us substitute the values in the midpoint formula, which is given by a very simple formula x1 plus x2 by 2 comma y1 plus y2 by 2. Therefore, now let us put P for consider point line DB. It is P plus 8 divided by 2 comma 3 plus 2 divided by 2. That is, simplifying, we write P plus 8 by 2 comma 5 by 2. That let it be equation 1. Now we have to find the midpoint of the line AC. Here we have x1 and y1, x2, y2. Therefore it will be 6 plus 9 by 2, and y1 plus y2 is y1 is 1 plus 4 divided by 2. This is substituted here and simplified. 6 plus 9 is 15, 15 by 2 comma 5 by 2. Therefore comparing 1 and 2, see comparing 1, here it is xy at the midpoint P plus 8 by 2 comma 5 by 2, x1 y1, this is x2 y2. Therefore x1 should be same for both the lines at the intersection point. Therefore this equation P plus 8 should be equal to 15. That is, numerator here is equal to numerator here, or P is equal to 15 minus 8, that is equal to 7. This is the answer. Now let us take up the next problem. Find the midpoint of line segment joining points 3 P, P 3, 4 and point Q 5, minus 2. We have to find the midpoint using the same old formula. P is given as 3, 4, Q is given as 5, minus 2. Midpoint is given by x1 plus x2 plus x1 divided by 2, comma y1 plus y2 by 2. Put the values. If you put it 5 plus 3 divided by 2 comma 4 minus 2 divided by 2, that is equal to 8 by 2 comma 2 by 2, that is 4 comma 1. The midpoint is given by 4 comma 1. Next question 7.7. Find the ratio which line segment joining minus minus 3 comma 10 and 6 comma minus 8 is divided by minus 1 comma 6. Here we have x1 y1 minus 3 t into 10 and x2 y2 6 and minus 8, and this is divided by the point P is minus 1 6. We are required to find out the value of m1 and m2. Please read the question once again yourself and let us solve it. Given A is minus 3 comma 10, B is 6 comma minus 8 divided by P is minus 1 comma 6. So we have to find out the values of m1 and m2. Therefore, let the required ratio be m1 is to m2. Formula is x is equal to m1 x2 plus m2 x1 divided by m1 plus m2, comma y is equal to m1 y2 plus m2 y1 divided by m1 plus m2. Substituting the values of x1 is equal to minus 1, y1 is equal to minus 6, the value of x, that is for point P, x as minus 1 and y is equal to minus 6, and x1 as minus 3 and x2 as 6, and y1 equals 10 and y2 is equal to minus 8. We will find out the values of m1 and m2. Here P is xy, therefore it is minus 1 and y is is equal to 6. Therefore, minus 1 is equal to m1 into 6 plus m2 into minus 3 divided by m1 plus m2. Therefore, minus m1, this is cross multiplying here, minus m1 minus m2 is equal to 6m1 plus minus 3m2. Therefore, taking m1 on the right side, we get 7m1 is equal to this m2 on the left side, we get 2m2. 7m1 is equal to 2m2. Therefore, the ratio of m1 is to m2 is 2 is to 7. This is the answer. 7.8. Show that the points 1, 7, 4, 2, minus 1, minus 1 and minus 4, 4 are the vertices of a square. We know a square has 4 vertices. He has given 4 points and the coordinates of the 4 points are given. Now we have to prove that these form a square. To form a square, we have to show that the length of each side is equal. That is, if there are 4 points of a square A, B, C, D, then we have to prove AB is equal to BC is equal to CD equal to DA. So if this is given, A is 1, 7, B 4, 2, C and D are, we know the values. See the figure here, this is a square of each. Here, if we want to prove that it is a square, we have to prove AB is equal to DC is equal to BC is equal to AD. These 4 sides are equal, and we also have to prove AC is equal to DB. That is implied. Therefore, to prove AB is equal to BC is equal to CD is equal to DA, diagonals are BC and BD equals AC. Therefore, the distance between AB is given by x2 minus x1 whole square plus y2 minus y1 whole square. Let it be equation 1. Therefore, substituting the values of A and B. A and B is A is 1 comma 7 and B is 4 comma 2. And these values, if you substitute, 4 minus 1 whole square plus 2 minus 7 whole square. This 4 minus 1 is 3 square, 2 minus 7 is 5, 5 whole square is minus 5 whole square is plus 25. That is equal to root 34. Similarly, we will substitute the values of B and C, that is coordinates of point B and C. Here we get x3 minus x2 whole square is equal to y3 minus y2 whole square. That is equal to y3, x3 is minus 1 and x2 is minus 4. Whole square plus y3 is minus 1 and y2 is 7. Sorry, y2 is 2. Here y2 is 2. Therefore, that becomes square root of 25 plus 9. That is equal to square root of 34. Therefore, we have calculated BC as square root of 34. CD. Similarly, if we take this line CD, it is x4 minus x3 minus x3 plus y4 minus y3. x4 minus x3 whole square plus y4 minus y3 whole square. x4 is minus 4 and x3 is minus of minus 1, that is plus 1 whole square plus y4 is 4. y4 is 4 and minus of minus 1 is plus 1 whole square. Therefore, this becomes minus 4 plus 1 is minus 3. Minus 3 whole square is plus 9 plus 4 plus 1 is 5. 5 into 5 is 25. That is equal to square root of 34. So, CD is also equal to square root of 34. Therefore, dA, we have to find dA. Substitute this formula is x1 minus x4 whole square plus y1 minus y4 whole square under root equals 1 plus 4 whole square plus 7 minus 4 whole square. That is equal to 4 plus 1 is 5, 5 square is 25, 7 minus 4 is 3, 3 square is 9. That is equal to 30, square root of 34. Therefore, AB is square root of 34, BC is square root of 34 and CD is square root of 34 and DA is equal to square root of 34. Therefore, AB is equal to BC is equal to CD is equal to DA. Hence, these form the vertices of a square. For a cross check, we can also find out the length, the diagonal length AC should be equal to the diagonal BD. Let us find out the value, the distance of AC and BD. Therefore, is equal to BD is equal to x2 minus x4 whole square plus y2 minus y4 whole square. That is equal to 4 plus 4 whole square plus 2 minus 4 whole square. Here 2 minus 4 is minus 2, minus 2 whole square is plus 4. Therefore, it is 64 plus 4 square root of 68. AC is given by square root of within bracket x3 minus x1 whole square plus y3 minus 1 y1 whole square, that is minus 1 minus 1, that is minus 2 whole square. Minus 2 whole square is 4. Minus 1, y3 is minus 1, y1 is minus 7 and minus of minus, that becomes minus 7 minus 8. Minus 8 whole square is 64. Minus 2 whole square is 4. That becomes, it is 4 plus 64. That is equal to 68. Therefore, we have proved AB is equal to BC is equal to CD equal to DA is equal to root 34, square root of 34, and diagonal AC is equal to AD, BD equals root 68. Hence, we have proved that these form the vertices of a square. Seven point nine. Solve the following. Find the relation between x and y such that the point xy is equidistant from the points 7, 1 and b within bracket 3, 5. Equidistance means it is located on the line AB. Point A is 7, 1 and point B is 7, 3, 5 and P is such a way that it is located exactly in between A and B. Let us solve it. See here the line A and B. It is given as A as 7, 1. Here you see 7, 1. This is A and this is 3 and 5. Sometimes they will give it as a and B or 2 points as simply coordinate they will give. We have to assume it as A and B. So A and B we have known and P is located here. We have to find x and y such that it is located exactly at a midpoint of B, A and B. Let us do the problem. Let P within bracket x and y be the point which is equidistant from points 7, 1 and B of 3, 5 as shown in the figure. Equidistance means AP is equal to BP. That is, if this point is P, then we have to prove AP is equal to BP or AP square is equal to BP square. We have to prove. Therefore, let us find out AP square. AP square we are finding here just to avoid the square root sign. Therefore, AP square is equal to base. AP we know x minus 7. If P is x and A is P is xy and A is 7, 1, then x minus 7 whole square, considering AP, x minus 7 whole square plus y minus 1 whole square, that is AP, equals x minus 3 whole square plus y minus 5 whole square. That is the distance formula we are using. Hence, we have to prove that. Therefore, this expanding we get x minus 7 whole square is x square plus 49 minus 14x. That is a square plus b square minus 2ab. A square is x square. B square is 7 into 7, 49 minus 2ab is 2 into 7, 14x plus y square. This y minus 1 whole square we have to expand using formula a square minus b square. Y square plus 1 minus 2y. Similarly, on the right hand side, we have to find x minus 3 whole square. This is x square plus 9 minus 6x plus y square plus 25, that is here 5 square 25 minus 10y. Therefore, simplifying we get, bring all the numerals on the one side. See, this x square and this x square get cancelled. Right hand side and left hand side get cancelled. Similarly, this y square and this y square get cancelled because both are same. On the one is on the left side and the other one is right side. If you bring to the one side, it becomes the sign changes. Hence, it gets cancelled. Therefore, 49 plus 1, 50 minus 9 minus 25 minus x. Here you take minus x into this is 14 minus 6 minus y into 2 minus 10 equals 0. This is 2 minus 2 we have taken, minus y we have taken common, therefore it will be 2. This becomes 10y. When it comes on the left side, it becomes plus 10y, and because we are taking minus sign, it becomes minus 10. Therefore, it becomes 8x minus 8y is equal to 16, or x minus y is equal to 2, which is the required relation. Therefore, we have to find we have to say that the relationship between for the point is x minus y is equal to 2 is the required relation. Please note that equation, this is, you see, equation x plus y is equal to 2 is a straight line which is equidistant from A and B, lies on the perpendicular bisector AB. Therefore, the graph x minus y equals 2 is a perpendicular bisector of AB. Because it is equidistant and this equation is the x minus y is equal to 2, hence it is a perpendicular bisector. Next sum. Find a point on y-axis which is equidistant from points A 6, 5 and B is minus 4, 3. Therefore, we know that a point on y-axis x is 0. Therefore, P is 0, y. Now, we have to substitute the formula. That is same, x1 minus x2 whole square plus y1 minus y2 whole square is equal to, on the right hand side, x2 minus x1 whole square plus 3 minus y whole square. That is, we are assuming P as here and we are finding AP and BP, and substituting these values we get 6 minus 0 whole square plus 5 minus y whole square equals minus 4 minus 0 whole square plus 3 minus y whole square. This is the equation. Here in this equation 7 is given. We have to put the point P's coordinate as 0 and y. That is, x is 0 here. Therefore, x minus 0 and y is here, y2 is y. So y is 5 here. You see, y is 5. 5 minus y. Therefore, simplifying, we get 61 minus 25, that is equal to 4y, or 4y is equal to 36 is equal to 4y, or y is equal to 9. Therefore, point P's coordinates are 0 and 9. This is the answer. We can check it also, whether AP and BP are equal. You do it homework by putting coordinates of A as 6, 5 and B as minus 4, 3 and P's coordinate as 0 and 9. You will get square root of 52 as the answer. AP is equal to square root of 52. BP is equal to square root of 52. Hence, P09 is the intersection of y-axis and perpendicular bisector of AB. Please note that. Here in the problem he has not asked to cross check, but if time permits or if time is there, if the calculations are simple, you can do it. Otherwise, the answer will end here only. 7.10. Solve the following. Find the area of triangle with vertices A within bracket 1, minus 1, B minus 4, 6 and C minus 3, 5. This is a 2-mark question. Here we have to find the area of triangle by simply substituting the coordinates, and we have to remember the formula. A is 1, minus 1, B is minus 4, 6 and C is minus 3, 5. This is the figure. You remember this and this equation, and it is very easy to, if you draw this figure, it is very easy to remember the formula. The area of triangle is given by half into x1 into y2 minus y3, x1 into y2 minus y3. Similarly, x2 into y3 minus y1 plus x3 into y1 to y2. This is the formula. Substitute the values. Half of x1 is 1 into y2, 6 minus 5 plus minus of 4 into 5 minus of minus 1 plus minus 3, that is x3, minus 3 into minus 1 minus 6. This is the formula. There is no square, nothing. Simply you have to subtract and remember the formula. Therefore, half into 1 into 6 minus 5 is 1, minus 4 into 5 minus of minus 1 is plus 1, plus minus of 3 into minus 1 minus 6 is equal to minus 7. Therefore, half into 1 plus minus 4 into 6 plus minus into minus is plus 7 to 3 is 7 into 3 is 21. Therefore, it is half of 1 minus 24 plus 21, that is equal to 1 into the minus 24, that is equal to that is equal to 2, that is equal to 1. Therefore,